Hey y'all, welcome back. I'm Mr. Boyden, your math teacher, and today we're going to talk about rigid transformations. So what is a rigid transformation? It's just a transformation which produces a new image. So you take some shape, it produces a new version of that shape that is congruent to the original one. You could think of rigid as being the opposite of flexible. So I might add up here like rigid might mean non-flexible. And flexible would be where like if there's some sort of distortion or the shape or size changes. So I'm going to also add that on here so that it's where there is no change to shape or size. And there are three of these that we're going to learn about, and I have them down at the bottom. I'll zoom in a little bit for you here. The first one is called a translation. It's not translating like from Spanish to English or something like that. So that's our first one that we need to know about today. A translation, a lot of students understand this better if I write the word that it is a shift or a slide of the shape. And so we have an example above right here where the first triangle, it slid over here, it became the new one. Notice it didn't turn in any way, it didn't flip, and there's no change in the size. It literally just moved. It's a movement. In fact, all these are movements technically. Next one is a rotation. Okay, and the thing to see with a rotation is notice how they color coded these. So this shape actually turns as it's going around, and it's going to continue to turn. Okay, so it's moving in space while it's turning. That makes it a rotation. And then the last one is a reflection. Some people like to call this mirroring or flipping the shape. Some people call it a flip. Okay, and so this shape was flipped over to there. The way that I like to talk about this to help people understand it, or at least to understand what happens after this, is that every point on the original shape, so I'm going to call that the point, it will have a partner point that is exactly the same distance on the other side of the line. So for example, if this distance is 3, this distance is also 3. Later in the video, we're going to see that that's how we actually generate the image on a reflection. So original, that came first in each of these. The image comes second. Sometimes the original will also be called the pre-image. So if you see that language in a book that you're reading, or if you have a test where that comes up, that's all that means. So pre-image just means it came first, then the image came afterward, after the transformation. So, guys, one thing that I got confused when I was younger is I'd be like, wait, I thought you said transformation, translation, which is which? The deal is all three of these, translation, rotation, and reflection, all three of them are transformations. Transformation is just describing the different things that can happen to a shape. There's another thing we need to talk about called rotational symmetry, and that is if you just rotate a shape where it is and it lines up with itself again, or it looks the same. So for example, if we took this shape and we rotated it this amount, in this case I believe that's 60 degrees, so all these points would shift and they would all land on each other. Okay, so and you could do that 1 and it would land there, 2, 3, 4, 5, 6. So this example has what we would call 6-fold rotational symmetry. And what that means is because a circle is 360, 6-fold, it can go 6 times, that means the angle of rotation to get there is 60 degrees. So let's dive right in and do a real example. This is an example of a question that would be a reasonable exercise. It'd be the type of thing that could be on a test. So if you have graph paper, go ahead and get that out now if you didn't get it already, because you'll probably want to use that today. And then we're going to get started. So draw your X and Y axis. Now we're going to start graphing these points. You may, as we go through this, you may want to pause after each step that I do and try the next one on your own, or if it feels overwhelming, then just follow along. Okay, let's start graphing. So points Q at -3, 0. So I'm going to call that point Q. R at -5, -2. And S at -1, -4. And they said it's a triangle, so I'm going to connect the dots. All right. So now what? We're going to go through parts A, B, and C in order. First, and let's color code it so these stand out, okay? So we'll do the first one in red. It says translate up by 5 units, or up 5 and 6 right. So we're going to take each of these points, and from each one, I'm going to count up 5 and right 6. So I'm going to start here. I'm going to go up 1, 2, I'm going to start with S, by the way. So up 1, 2, 3, 4, 5, right 1, 2, 3, 4, 5, 6. Now, that was point S. It just moved. So what we're going to do is we're going to call that S, but we have to put a mark to say that it's not the same point. The way we say this is S prime. We're going to do the same thing with the other points. Be careful when you count. Sometimes people overcount this, which is weird. So be careful. From Q, we're going to go up 1, 2, 3, 4, 5, right 6, right 1, 2, 3, 4, 5, 6. There's Q prime. And I'm going to take a moment. I'm going to put R prime on here as well. R prime is right here. So double check your picture. You may want to pause the video and make sure yours is in the same spot as mine. One thing you can do, like when you're not following along with the video, make sure that this actually looks like a translation. Because remember, we saw in the beginning of the video, a translation meant the shape moved, but didn't rotate or change size. So if your shape is at all distorted, there's a mistake somewhere. Okay, so there's that first one. Now we're going to do a reflection. I'll do my reflection in purple. So reflect that result, so we're reflecting the thing in red, across the x-axis. Now the x-axis is this one. So remember, this is like flipping or mirroring. Those mean the same thing as reflecting. We're going to flip this onto the other side of the axis. So here's how I do that. I'm going to start again with point S, and the first thing I'm going to do is I'm going to count how far away is this point from the x-axis. Whoop, just 1 away, which means its partner point will be 1 away on the other side. So the new point, which we're going to call S double prime, is right there. I'm going to do the same thing with R prime. So I'm going to count 1, 2, 3 to the x-axis. So that's 3 away. I need to count 1, 2, 3 again. There's the new point for R prime. Except it's double prime, sorry. Same with Q. Q counting down to the axis is 1, 2, 3, 4, 5. So I'm going to count 1, 2, and I don't know if you can see that. 1, 2, 3, 4, 5 again. And there is Q prime. So what we should see when we connect the dots, or Q double prime, sorry about that, I made the same mistake again. So when we connect these, what we should see is the same shape, but it looks like it's been flipped. All right, and then let's do the last part, do that part in black. We're going to rotate the result 180 degrees about the origin. So guys, you almost have to imagine like there's a circle on here, and right now the purple is down here. It's going to rotate halfway around the circle up to here. So when I rotate this point R around, what ends up happening is it ends up exactly on the opposite side of the origin for 180 degrees. So this point rotates around, so R prime rotates like this, almost like it's going around a circle. And so our triple prime ends up here. And what about S? S ends up out here. So I need to switch my colors again. And Q is going to be up here. And they are called triple prime because that's our third change to the shape. So Q triple prime, and then I'm going to put S triple prime right here. So guys, again, that basically is a test style of question. That would be a common thing we'd put on a test. So just be aware of that. And we will do another example later in the video. For now, let's just do some describing. So I want to give you a chance to try this before I take it away. So to describe this transformation, what we're going to do is we're going to say, is it a translation, rotation, or reflection? And then we're going to say how much of that is happening. So take a minute, decide what you think it is. You'll also have to decide which shape came first, the blue or the red. In this case, the red shape came second. Okay, blue shape came first. How do I know that? See right there, it says B prime. That means it came later. Okay, this is a translation because it's a shift, so we're going to use the fancy name though, translation. And one thing that I like to do that helps me see a translation is if I draw in from point to point and then I make a right triangle that connects them. And that makes it a lot easier to count them. So this went 1, 2, 3, 4, 5 to the right. So 5 right. And down 3, I think. 1, 2, 3. Yep. Down 3. Now, we don't need to do it for all of the points. If it's a true translation, it's going to be the same numbers for all the points. So you just pick any point and its image, or its partner point, so B and B prime in my case, and count it and you're good. I do want to show you like the fancy math way of doing this. So we just wrote this out in words. There is also a fancy math way, which we're going to be doing soon and will be required soon. So good to see it now. What it says is the point xy, whatever it is, it turns into x plus 5, notice that's that same 5 right there, and y minus 3. So you may remember from graphing that x is left and right, and so that's why plus 5 represents going 5 to the right. And you may remember from graphing that the y value tells you how far it goes up and down, and that's why a y minus 3 right there is saying that it goes down 3. Let's describe some more. Here's 2 more. I want to give you a chance. Please pause the video and try to figure out what you think transformation is happening here. All right, this first one is a reflection across x. And look at that. Each point has its partner point on the other side of the x-axis. So that's what it's going across. It's moving over the x-axis. What about the second one? Okay, 3 goes to 3, 2 goes to 2, 1 goes to 1. That's a reflect over the y-axis. So notice when I draw those lines, they're all crossing over the y-axis right there. That's how we know that it's the y-axis that we are reflecting across. All right, one more example. Okay, I'd like to encourage you to try this one on your own first, and then we'll be going over it together, of course. You already know that. So I'm going to get started. Point A is at -2, 5. And by the way, guys, this is basically the same question we were dealing with before. So it's just another example for you. Point A. Point B, -2, 1. And -4, 4. Oh, except I missed. All right, they asked us to reflect across the y-axis. Pause the video if you haven't done that yet. Try it on your own first. Okay, so what I'm going to do, I'm going to notice that A is 2 away, so 2 more, and there's point A prime. C is 1, 2, 3, 4 away, so 1, 2, 3, 4 away. There's C prime. B is 2 away, so I'm going to go 2 away, and there is B prime. Make sure you connect the dots as you go. All right, let's do C. Wow, translate down 8, that's big. All right, translate down 8, excuse me. Then translate 8 units to the right and 2 units down. Oh, okay, guess I'm going to make a change here. I'm going to do translate 8 units to the left, simply because for myself, my own class, I would never write a question like this. It goes way off the grid that was given. So let's go 8 units left right now and 2 units down. So I'm going to go 8 to the left, and let's do this in a different color. Let's use green. Okay, so 8 units left. So 1, 2, 3, 4, 5, 6, 7, 8, and then 2 down. So there's B double prime. Now I'm noticing here, guys, A is 1, 2, 3, 4 units above B prime. So this is a shortcut I'm going to show you. Rather than translating A, since I know it didn't rotate, it only translated, I could just count up 4 right here. 1, 2, 3, 4. And it's guaranteed that A double prime is going to be there because it has to have the same relationship that it did to B over here. I can do the same thing for this one, by the way. You can count left and down if you want for C prime, or you can realize that to get from A double prime to C double prime is 2 to the right and 1 down. So I'm going to go 1, 2 to the right and 1 down. So there's C double prime. And then I'm going to just take a minute and clean this up. I've done a lot of extra annotations on here that I normally wouldn't have if I was doing like a test question. So I've done it just to explain. So let me get those little counting bubbles out of there. Or if we were in a classroom, you'd actually see me with my fingers, so you wouldn't need those bubbles that I drew. And then what's our last thing? We're going to rotate the triangle 90 degrees counterclockwise. Now, 90 degrees, guys, remember that's a quarter turn. And counterclockwise is going to be this way. So these points are going to rotate downward. So this is going to rotate down to here. So there's B triple prime. Point C is going to rotate down. Now this is interesting. So they're going to be in different quadrants again. So now I'm going to rotate this down. It's going to be right here. And then A, when it rotates down, it's going to be right here. So a lot of times in class, students will ask me, hey, Mr. Boyden, what's the answer to this question? Well, the answer to the question is all of it. Okay, you'd need all of these things because it's a three-part question, so each of these images is an answer to one part of the question. So guys, I know that's brief, but that's just our introduction today to transformations. We talked about translations, which is a shift. We talked about rotations, and we talked about reflection, which is either mirroring or a flip, or, well, you can call it a reflection, which would be great too. Hope you enjoyed the video, and I will see you next time.